we would like to talk about decimals. So I have some standard decimals written here for you. Now, straight up, decimals are nothing but fractions. That's all it is. It's a different way to write a fraction that's base 10 or denominator with a 10. Okay, so 0.1, y'all, that's the lazy way of reading that. That's 1/10. I mean, not just the 1/10 in fraction form, but we should read this statement as 1/10. Now, I do it too. I'll say 0.1, but really that is 1/10. So if you see 0.01, that's actually 1/100th. So you need to know place value. So this is the tenths place. And then the 1 is in the hundredths. I'm writing this super tiny hundredths place. So that is defined to be 1/100 or 1/100th. And I've got it written over there for you. Now I count here. Again, you start counting after the decimal. This is tenths, hundredths, thousandths. So this is the fraction 1/1000th. Okay, so 1/1000th is what we're saying there. So instead of reading it 0.001, which I know we all do it, we should get in the habit of saying, hey, that's 1. Then you might have to count quickly in your head, tenths, hundredths, thousandths. Okay, and then this is 10,000ths. Why? Because this is tenths. Remember, there is no once. That's not a word. This is the ones place, but there's no once. It starts with tenths, hundredths, thousandths, 10,000ths. So that is 1/10,000th. So if you're ever asked to change a decimal to a fraction, if you read it properly, that will never be a problem. If you read it as 0.0001, you glean no information from that. But if you read it as 0 is 1/10,000th, then you just write 1/10,000th when you change that to a fraction. Okay? And here is a nice depiction of that place value that I was discussing. So if you'll notice right here in red, I'm circling it as your decimal. Whenever you read a decimal, you say and. On the left, it went a long way, but you notice you start with this pink, the ones, tens, hundreds. Then you have the thousands group. So that's thousands, 10,000, 100,000s in green. Then you have the millions group, millions, 10 millions, 100 millions, and you have the billions group. You got billions, 10 billions, 100 billions. Anybody know what's larger than the billions group? It's the trillions group, you're right. So then you would have trillions, 10 trillions, 100 trillions. And then you could go quadrillions, and then it gets to numbers that I can't remember the order. Usually we change to something called scientific notation when it gets that large anyway. But what we're spending our time today talking about is this side. So there's those tenths that we discussed, and then hundredths. Notice the THS. Okay, that's what makes it a decimal. Thousandths, 10,000ths, 100,000ths, and millionths. And these are really tiny numbers to the right of the decimal. So here we go, some problems. We're supposed to write the word name for this following number right here. Excuse my handwriting. I'm writing on we're using a stylus on a squirrely tablet, so do the best I can. But let's read this number. Now remember, the decimal is an and. So this is 202,324 and what? Now, don't read 0.521. Again, that's where we get lazy. You have to look at where you end up. So this is the tenths, hundredths. This is in the thousandths place. And that's how we name this thing. So that would be and 521 thousandths. Okay, so I'm going to write that down. That's 202, already getting sloppy, thousandths, thousands, not thousandths, thousands, I didn't say that properly, 202 thousands, 300, again, bear with me, 24, 24 is hyphenated, and, so again, that decimal is an and, 521, again hyphenated for 21 thousandths. Okay, so 202 thousandths, 324, and 521 thousandths. Okay, so again, notice the thousandths compared to the thousands is different. All right, let's look at the next one. So I'm supposed to write the word name for the following number. This is more interesting. By the way, when you do this in the homework, you will not have to type all that out, thank goodness. You'll have multiple choice and you can select the appropriate one. So do it yourself first and then check so you don't find yourself getting confused between the options. Write the word name for the following number. Now, I've got to count over. So I've got 0 and. Now, if it's 0, I don't have to write anything before the and, so I don't have to put 0 and. I'm just going to put what this is. So I'm going to count tenths. This is tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. And that's the number 34, right? So I've got 34, again hyphenated because two-digit numbers are hyphenated, 34 hundred thousandths. Like that. Okay, so let's count it again. So I've got tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. Yes, that 4 is in the 100 thousandth spot. And then I ignore all the zeros and the decimals over here to the left and just say that's 34 hundred thousandths. Now this may be a little easier. This time I'm giving you the written name for this, the word name, and you just tell me the number. So we've got 352,034, and remember this is my decimal. And should be nowhere else but the decimal. And 590 10 thousandths. So the first part we've got this 352,000, so 352, that's the thousands group, so I'll put a comma. 34, okay, so there's nothing in the hundreds group, so I put 0, 3, 4, and there's my decimal. 590 10 thousandths. So I know I have to write 590 down, but here's the deal, is that the 0, so I've got 590. This guy right here needs to be in the 10 thousandths place. Okay, so that means I've got to put some zeros over here. How many? So if I say tenths, hundredths, thousandths, 10 thousandths, that doesn't work, right? So I just do tenths. This would be the hundredths, the thousandths, the 10 thousandths. That works. Do you see what I'm saying? Because we just need a 0 for the tenths place because this is 590. Okay. So you got to play around with that a little bit. You might want to leave space, you count it out. That can be tricky sometimes. Okay, let's try this again. So I've got 4 and 4,000. Does that even make sense? Yes, 4 and. So the and, that's my decimal, right? So 4 and. So there's my 4, and there's my decimal. I'm going to move him down a little bit so it doesn't look like a big multiplication symbol. There's my decimal. 4,231 hundred thousandths. Woo! Okay, so 4,231. How do I write that? So it's 4,231, and no commas go when you're talking about to the right of a decimal. But I just know that that 1 needs to be in the 100 thousandths spot. Okay? So if I do, if 4's in the tenths, hundredths, thousandths, 10 thousandths, that's not enough, right? It needs to be moved over 1, which means a 0 goes right here. I know that's a mess. So 4.04231. Remember, that's the lazy man's way of reading it. So that'd be 4 and. Now this is definitely 4,231. Okay, and I count tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. Yes, we did it right. That 1 needs to be in the 100 thousandths place. A little tricky. Maybe the homework's not that bad. Okay, rounding. I have found in my many years of teaching that rounding is very confusing for students. I want to make it as easy as I can for you. Okay, so here's a method. Here's what you need to do. When you have to round, I'm going to rewrite this number. No, I can erase. Let's find the tenths place. If I'm supposed to round to the tenths place, I want to underline the tenths. Notice the THS, which means it's to the right of the decimal, and the tenths, remember, is the first guy in line. So there's a 0 in the tenths place. Now I look directly to the right, to the number just to the right, and that's a 9. Now if that number, that says right, if that number is 5 or bigger, this number goes up, okay? Well, 9 is definitely 5 or bigger, right? So the 0 goes up to a 1. So we have the left stays exactly as it is, so you don't leave that off. That's 389, and then your decimal 1. So we would read that 389 and 1/10. But again, notice what I did. The first thing I did is underlined where I want to round. I'll look at the number directly to the right. So this 458 over here, that's not an issue. That doesn't matter at all. I'm only looking at this guy right here. If that is 5 or bigger, then that 0 goes up. What would happen if it was smaller than 5? Well, the 0 would stay a 0. So you never go down. You either stay where you are or you go up 1. So let us try this again. Okay, so I'm going to erase what I've got written right on top of my original problem. This time I'm rounding to the hundreds place. Hundredths, not hundreds, hundredths, which means it's to the right of the decimal. I got to find the hundredths place. So I've got tenths, hundredths. That's that 9, right? Now I'm looking directly to the right. I'm looking at the number right beside it. I don't care about anything else. I'm just looking at that 4. Now since that number is not 5 or larger, it's less than 5, then that 9 stays a 9. And so when I write down my answer, the 389 on the left remains, the 0 remains, and remember the 9 stays a 9 because of the number we highlighted. The 4 is below 5, so everything stays as it is. Now when it says round to the hundredths place, you should not have anything past the hundredths place. That should be your last number that you have listed. Just when it said round to the tenths, then the 1 was the last number we had listed, which is in the tenths place. All right, let's try this again. I'm going to erase my original problem, all the scribble I did there. And let's take a look at the hundreds place. So what digit, when you look at this thing, what digit is in the hundreds? Not dreths, but dreads place. Well, that's the 3. Right? And I'm supposed to look directly to the right. I'm supposed to look at that 8. And since that number is 5 or larger, 8 is definitely 5 or larger, then this 3 goes up to a 4. So now I have 4. Okay. Now, I don't stop there because when you're rounding to the left of a decimal, you still have to have all those place values. Like that 4's got to be in the hundreds place. So I put 0, 0. There's no reason to put the decimal or anything past that because I rounded to the hundreds place. Now notice the difference. When you round to a decimal place, that's the last number you have in line. But when you round on the other side, to the left side of the decimal, then you might have zeros. And if you round to the ones place, you will not be writing anything past the ones place. But if you round to the tenths place, you're going to have a 0 in the ones place. If you round to the hundreds place, you'll have a 0 in the tens and the ones. If you round to the thousands, you'd have zeros in the hundreds, tens, and ones. Okay? Again, I understand why it's confusing, because it is very confusing. All right, let's do some purple. Okay, next problem. The thousandths place. So first of all, decide what digit is in the thousandths. Notice the THS means we're dealing with a decimal. So 0 is in the tenths, 9 is in the hundredths, 4 is in the thousandths. There we go. So I'm looking, that's where I'm going to round. So that 4 either stays a 4 or it goes up to a 5. That's the only two options here. Now, how do I decide? Well, I look to the right of that at this 5 right here. And anytime it's 5 or larger, so the 5 is included, then you go up. Okay, so when I write this answer, everything to the left of the decimal stays exactly the same, 389, and And then we said we round up, right? So we have 0, 9, and that 4 is now going to be a 5. And notice I don't write anything past the thousandths place. All right, and because rounding can be so confusing, I made sure I asked this twice. So I have a different number for you. I do think it's worth it for you to pause, grab a piece of paper, and hopefully you already have some paper and we're taking notes. But go ahead and work these out on your own. See how you do. All right, so how'd it go? Now here's the idea. I've got this number, and I'm going to read it to you. So it's 1,890, and now you got to do a little secret count, tenths, hundredths, thousandths, 10 thousandths. So this is 9,985 10,000ths. Okay, so again, the whole number, 1,890 and 9,985 10,000ths is that number. Now, they didn't ask for that, but I thought I'd just add that in as bonus. The ones place. Let's take a look at the ones place. What number is in the ones place? A 0. Okay. And I'm supposed to look directly beside it at that 9. Now, if that number directly beside it is 5 or larger, then that 0 goes up to a 1. And that is the case, right? So my answer is 1,891. There's no reason to put a decimal or anything past it because we're rounding to the ones place. That means we chop off everything past it. Now let's try this again for the thousandths. Notice the THS right here, this THS. That means we're talking about to the right of the decimal. The thousandths place will count over. Tenths, hundredths, 8 is in the thousandths place, which means I'm looking directly beside the 8 to the right of the 8, and if that number is 5 or larger, that 8 should go up to a 9, and of course 5 is 5 or larger. So here we go. The remainder of the number stays exactly as is, so that's 1,890, and my decimal place, 999 thousandths. Okay, check to make sure your last number is in the thousandths place. That's tenths, hundredths, thousandths, yes. And that 8, again, as promised, went up to a 9. You shouldn't have anything past that, okay? Because when you round to the thousandths place, that should be the last number on your list. When you round to the ones place, the 1 should be the last, the ones, not the number 1, but the ones place should be the last number listed. The hundredths place, so again, let's try it again. So first of all, THS. What number's in the hundredths place? So tenths, hundredths, that second 9 right there is in the hundredths place. I'm supposed to look directly to the right for that 8. And if that number highlighted in green there is 5 or larger, that 9 rolls up. Uh-oh. Well, what happens when I roll that 9 up? It goes to a 10, right? Which means that it goes to this place, the tenths place, which rolls that one up. Okay, so watch this. So, again, arrow here. That 9 goes up to a 10, which makes that 9 go up to a 10, which makes that 0 go up to a 1. You follow all that? That's what happens when you have 9s. You have to roll into the next digit or the next value, place value, to the left. And whenever you have 9s, you have to keep rolling up until you have a place that doesn't have a 9, and then that can go up and stop that process. So how do I write this answer? Well, I've still got the 189. Now that 0 went up to a 1, but then I have 0, 0. Why? Because it still has to go to the hundredths place. We rounded to here, not to here. So the hundredths place, there we go. So I know it is accurate to that place. I still have to put those 0, 0s because that's where I rounded. Again, I know, it can be a little bit confusing, huh? So let's try the last problem on the list, the tenths place. What do? You underline the digit in the tenths place. That is that 9, that first 9. Actually, it's the second 9. There's one over here as well. All right. Then I'm supposed to do what? I'm supposed to look at the number just to the right. Now, if that number just to the right that's highlighted is 5 or larger, that 9 has to go up. Okay. Well, here we go again. So if that is definitely larger than 5, 5 or larger, so that 9 goes up to a 10, which makes that one go up, right? So my answer is going to be 1,891.0. 0. Now, I don't put 0, 0, right, because I rounded to the tenths place. So I know when I look at this number that it is accurate to the tenths place as opposed to this one to the hundredths. Now, is there a difference between these values? No, they're still the same thing. They're 1,891 is really all they are. But accuracy makes a big difference, especially when you're dealing with certain things like chemicals or explosives, for goodness sakes. So that matters a lot. Okay. All right, how do you add or subtract decimals? Now, one thing is I'm not going to stress out a whole lot over this because at this point you do have access to calculators to do these decimals, and you learned this a long time ago. On the other hand, I don't want you to rely on your calculator for everything that you do in mathematics, so the how I still would like you to know. So how do you add or subtract decimals? Well, most of you know you line up the decimal point. And when you add, the order you do that in doesn't matter. So a lot of you have been taught to put the larger number on top and the smaller number underneath. That's fine. Nothing wrong with having the 3.5 on top. It just looks strange. Now what happens is you line up the decimals and the decimal place comes down in the line. And then of course you add 8 plus 5, which we have to carry. Remember that's 13, so I keep the 3 and carry the 1. Because that's really 1.3 when you think about what that is. And then 1 plus 1 is 2 plus 3 is 5, and then 2 plus 0 is 2. Again, you really need to know how to do that just in case, okay? With the age of cell phones now, we almost always have a calculator walking around with us if you need it, but still should know how to do it. Again, another addition problem. Now, these all have the same amount of digits, so it doesn't matter as much that I put the bigger number on top, and in this case I'm not. I'm just keeping it in order. What truly matters most is that you line these decimals up. That is required. So 1 plus 8 is 9. 9 plus 9 is 18, but I have to carry that 1. 1 plus 5 is 6, plus 9 is 15. I carry the 1, and 8 plus 8 is 16. Make sure you bring that decimal place down. Don't round. Don't ever round an answer unless it asks you to round the answer. Otherwise, it's wrong because you have to put the exact answer. What about subtraction? Again, I know you can type this in your calculator, and I do want you to type it correctly in your calculator, but what if you don't have your calculator? You still should know how to do this. Now, you can't switch around subtraction. Subtraction has to stay in this order. So I have 20 minus 11.8. Notice again, I'm lining up my place value. So this 20, you're like, uh-oh, it doesn't have a decimal. You can always put the decimal and zeros past that because the numerical value is the same. Okay? Now I have to borrow, right? I can't subtract 8 from 0, so what do? I make that a 10, right? And I borrow from the ones place, but I have nothing there either. So that I make that a 10 by borrowing here, and then I borrow over there, which makes that a 9. Remember doing that a long time ago? Now, the decimal stays lined up. 10 minus 8 is 2, 9 minus 1 is 8, and 1 minus 1 here is 0. But the difference between 20 and 11.8, y'all might even be able to visualize that. I kind of do on a number line, is definitely 8.2. This one, very similar, 40. Now, there's a decimal there if you need it, and 38.892. Again, I'm doing the lazy man's of reading that decimal. It's really 38 and 892 thousandths, right? Which means this 40 needs to go out to the thousandths place as well, or I can't subtract. Now, 2 from 0, I can't do that, so I have to borrow, right? I make that a 10. There's nothing there to borrow from, which means that's going to turn into a 9, that's going to turn into a 9, that's going to turn into a 9. Basically, we're taking it from the previous one, or the higher place value, and that 4 is going to turn into a 3. So lots of borrowing. 10 minus 2 is 8. 9 minus 9 is 0. 9 minus 8 is 1. There's my decimal. 9 minus 8 is 1 again. And 3 minus 3 is gone. As you can imagine, the difference between 40 and 38 and some stuff is going to be 1 and some stuff. Okay, so probably correct without actually checking it. So what's even potentially more aggravating than adding or subtracting decimals is multiplying and dividing decimals. Again, I know you're going to have a calculator. I'd be a fool to think you're going to try to take this test without one. I would prefer you try it and then go back and just check it with a calculator. But there's little things that would help to know. Like, for instance, you don't need a calculator to multiply 3.65 times 10. When you multiply by 10, 100, 1,000, 10,000, it's as simple as it moves the decimal place to the right. So 3.65 times 10 is 36.5. I just moved that over one place to the right. Or 3.65 times 100, and again, being lazy, right? This is 3 and 65 hundredths times 100 is going to be 365. Or 3 and 65 hundredths times 1,000. Now, I've got two places to move it, but how do I move it again? I must add a 0. So 3,650. That's something you should know without a calculator, really it is. Now this guy over here, I encourage the calculator stuff. There's no way, and again, unless I just don't have one on me, that I would even do this. I'm a math person, but I'm also not a human calculator, you know what I mean? And so, but how to, we need to discuss at least once. And so when you multiply decimals, you don't line up the decimal place, okay? You've got 1.3. What you do is this. You line up the last digit. So this happens to be in the thousandths. This happens to be in the tenths, but you line them up. And you remember the drill, right? 3 times 5. You're multiplying. Don't worry about the decimal right now. You're multiplying. 3 times 5 is 15, and that goes up there, right? 3 times 6 is 18, plus 1 is 19. That goes up the next spot. 3 times 3 is 9, plus 1 is 10, so the 0 comes down and the 1 comes up. And 3 times 2 is 6, plus 1 more is 7. You remember that? So again, I'm saying 3 times 5 is 15, but I carry the 1 from the 15 to, it's really not the tens place, but the next place in line. 3 times 6 is 18, plus 1 more is 19, carry the 1. I'm just checking. 3 times 3 is 9, plus 1 is 10, carry the 1. 3 times 2 is 6, 7. Yes. Now what do you do next? Well, you do that process over again, and y'all, I'm going to get rid of my 1s up here. Do that process over again with the 1 times each place value. But you scoot over, remember that? A lot of you put 0, some of you just scoot over. But you got to do that because you moved over a place. So 1 times 5 is 5, 1 times 6 is 6, 1 times 3 is 3, and 1 times 2 is 2. You add down, and it's probably been a long time since you've done this. It's been a long time since I've done it. 9 plus 5 is 14, carry the 1, 1 plus 6 is 7, 7 plus 3 is 10, carry the 1, plus 2 is 3. Now what? Is that my answer? No. Here's what the part that might be harder to remember. This is 3 places behind the decimal. This is 1 behind the decimal. You total those to get 4 behind the decimal, so I count from the right 1, 2, 3, 4, and there's my answer. Now that makes sense, right? This is 2 point something times 1 point something to give us 3 point something. Yeah, that makes pretty good sense, doesn't it? So I feel certain that's the answer. I still could have made a silly mistake. Again, the how-to. I want to make sure you remember that, but it is okay to use your calculator on something like that. So here we go with division. I have no desire to do a bunch of these by hand at all. I probably feel about as strongly about them as you do. Again, a calculator will get you there, okay? Now, I encourage calculators for number crunching, okay, but I don't encourage them for things that you don't know how to do. So like with fractions, I don't want you to use a calculator for fraction because people that do don't really understand fractions. Decimals, it's a process. Okay, but most people do understand the idea of a decimal, and what happens here is you just get kind of caught up in tedium. First of all, a negative divided by a negative always is a positive, right? We know this. We know this from not a question. It's a fact. It's an exclamation point. We know this from doing problems within integers, and you've done lots of integer problems. Now, when I set this up, again, yes, I'm doing long division. I'm dividing by, I'm going to ignore the negative, 0.04 into 23.492. Now, anybody remember how to handle that? I know you can't tell me, but I know some of you are thinking, yes, I remember what to do. What you do is whenever your divisor, that's what this guy is called, the thing you're dividing by is your divisor, you can't divide with a decimal as your divisor. Not in this process anyway, not the way we've been taught in this country. So you move the decimal over 2 places, which moves this decimal over 2 places as well. Essentially, we multiplied this number by 100, so it means we have to multiply this by 100 to get the same answer. So what I'm really doing is I'm dividing 4 into 2349.2. Much easier to do. The decimal in your quotient, which is the answer to a division problem, goes directly up. So 4 divides into 2. It doesn't, right? So we scoot over. 4 divides into 23 5 times. 5 times 4 is 20. Remember what you do next? You subtract. So the 3 comes down. 2 minus 2 is 0. And then we can pull down one number at a time. 4 divides into 34. How many times? 8, right? 4 times 8 is 32. What do I do now? I subtract. 4 minus 2 is 2. 3 minus 3 is gone. I move down the 9 this time. 4 divides into 29. How many times? See, 4 times 7 is 28, right? Okay, so 4 times 7 is 28. I'm running out of space. 9 minus 8 is 1. 2 minus 2 is gone. I move the next number in line down. 4 goes into 12 3 times. Now remember, that's past the decimal. And 3 times 4 is 12, and that gives me a remainder of 0. Okay? They get more complicated than this. But again, I don't want to spend an entire 30 minutes on dividing decimals. I just want to remind you of what's involved in dividing decimals. And if nothing else, while you're using your calculator, you can appreciate the fact that it's doing all that difficult work for you. But you do understand how to do it. Now here's something everybody doesn't remember how to do, but I have warned you about this. We're supposed to convert 0.432 to a fraction. Remember what I'm doing? Did you notice how I just read that? The lazy lady's way of reading a decimal. That's not what we want to do, right? 0.432 is not really that. It's really 432 thousandths, right? How do I know? Because the first place value after the decimal is the tenths, and then the 3 is in the hundredths, and the 2 is in the thousandths. So this is 432 thousandths. Boom, there's your fraction right there. Now, you are supposed to reduce that to lowest terms. So we do need to find what number divides into both 432 and 1,000 evenly. Okay, now your first thought might be 2, and that's okay. It might take us a while to get there, but that's okay. 432 divided by 2 would be, what, 216? 1,000 divided by 2 is 500. What I notice from that is that will divide by 2 again, right? So if I divide by 2 again, 216 divided by 2 is 108. 500 divided by 2 is 250. It'll divide by 2 again, won't it? 108 divided by 2 is 54. 250 divided by 2 is 125. Ha! Now, we know that those won't both divide by 2, right? Because 125 is an odd number. Is there a number that both will go into both 54 and 125? Not 2, okay, or not any even number. How about 3? Nope. And here's a quick check. I know 3 divides into 54 because 5 plus 4 is 9, and the sum of that divides by 3. 3 does not divide into 125 because 1 plus 2 is 3 plus 5 is 8. And 3 doesn't divide into 8. That's a cute little trick. It only works for 3s and 9s. That story does not work for any other numbers as far as division goes. It's called a divisor test. So I feel like 54 and 125 is completely reduced. Let's do this again, okay? Convert, again, the lazy lady, 0.0008. Okay, that's not right, right? That's really 8. Now, what place is this in? Tenths, hundredths, thousandths, 10 thousandths, right? 8 10 thousandths. Well, I know that reduces. I sure do, because I think 8 divides into 10,000. You ought to check it. If you have a calculator on you, it's worth doing. Yeah, so 8 divided by 8 is 1. And if you type that in your calculator, 10,000 divided by 8 is 1,250. So save myself some trouble by just checking 8. But you could have divided that in half, 4 over half of that's 5,000, which will go again, and then 2 over 2,500, and then finally 1 over 1,250. So it's all about reading this decimal correctly instead of the lazy lady's way. Now here is the reverse question. Okay, this question is asking that we convert fractions to decimals. Now, if you're going to have your calculator on you, this is not a bad problem because remember, this is just division. If you don't have a calculator on you, then you got to know how to divide, long division. So that's 8 divided into 5, right? But now in your calculator, y'all just do 5 divided by 8. Now, it tells me this when I look at my calculator. And don't forget this dude right here. That negative is still part of that. But now, had you done the long division, you would have gotten that. And you're thinking, how in the world? Remember, when you do this, you have to add, because 8 doesn't go into 5, so you have to add the decimal and the 0. Then you say 8 goes into 50. How many times does 8 go into 50? Well, 6 times 8 is 48. See where this is going? The decimal lines up. You would get there, okay? But I don't mind you doing 5 divided by 8. Now, here's where people go wrong. They do 8 divided by 5. You don't do that. It's always the numerator. Write this down big. Numerator divided by denominator. All right, so if I do 3/5, you type in 3 divided by 5 in your calculator and you get 0.6, but that would be wrong, right? Why? Because I didn't put the decimal. Don't round those unless they ask you to, and I did not ask you to, so you write the entire number down. Here's another one, right? Write 32/5 as a decimal. Now, if you wanted to divide 5 into 32 because you didn't have a calculator on you, that's how you would do it. You would eventually have to add the decimal and then the zeros after that until it stops. But here's what I wanted you to notice. When I type in 32 divided by 5, I get 6.4. Okay? Is that what you expected? Well, anytime the numerator is bigger than the denominator, then you're going to have a number bigger than 0, right? Like if I gave you instead down here, let's do this a different color, 5 over 32, that's called a proper fraction. And proper fractions are between 0 and 1, where the numerator is smaller than the denominator. But this guy's called an improper. By the way, it's a bad name because there's nothing wrong with an improper as long as it's reduced all the way down. But for an improper fraction, your number's always going to be bigger than 1. 6 in this case. Okay? Now, what happens here when you have a mixed problem? You've got a fraction added to a decimal. Well, you need to convert one way or the other. And if you've got a calculator living with you, it's easier to convert a fraction to a decimal. Remember how to do it? 3 divided by 8. Boom, that's it. So now I have 0.375. That's the lazy lady, right? This is really 375 thousandths. Plus 4.9, again, lazy lady, that would be 4 9/10. When I add that in my calculator, it gives me this answer, 5.275, which is really 5 and 275 thousandths. Okay, we've got something new. Percent. What is a percent? A good way to think about it is a ratio whose denominator is 100. Okay, real simple. The percent sign means out of 100. All right, so if we're supposed to write 7% as a fraction, then we say 7 out of 100. That's what that means. 7 out of 100. Percent sign, that just means out of 100. You just take those 2 zeros, make that a line, put it in the denominator. That's all that's really going on. Now, to write that as a decimal, think about our definition of decimals. This is 700ths, right? So that'd be 0.07, because I put the 7 there, that'd be 7/10. But this is 700ths. Now, a lot of people think about this. There's a quick way to do it. If you have 7%, what could you do to quickly to get it to here? And you move the decimal. That says decimal. Let's fix that. You move the decimal 2 places left. What if you're thinking there is no decimal? Well, there is. If a number doesn't have a decimal, it's at the end of the number. So there's a decimal if I move it 1, 2, right? And I put that secret 0 right there. There's my answer, 0.07. But all that is because it means out of 100. So if I convert 67% as a fraction, or write 67, I should have said convert 67% to a fraction, or write 67% as a fraction. I got confused when I typed it up. But that's going to be 67 hundredths. Now, if that would reduce to lowest terms, I would, just like the 7 out of 100, neither one of them reduce. There's not a number that divides into both 67 and 100, so that's it. If I had to change it to a decimal, it'd be 0.67. It didn't ask for that. Okay, we could have stopped right there. All right, what about write 2.8% as a fraction? What? Okay, so let me show you. So it's out of 100, right? So I have 2.8 out of 100. But that's not allowed as a fraction. I'm not allowed to have a decimal as a fraction. So how could I get rid of that decimal? Well, if I move that over one place in the top, I'd have to move it over one place at the bottom. Essentially, what I'm saying to do is multiply by 10. What? So you move it over one place or multiply by 10, that'd give me 28. And I move this guy over one place or multiply by 10, that'd give me 1,000. And then there's the fraction. Now I'm circling it, but I don't need to. You know why? Because it's not lowest terms. I still have to reduce it to lowest terms. So I need the number that divides into both 28 and 1,000. And the number that comes to my mind is 4 goes into 28 7 times, and 4 goes into 1,250 times. So that is lowest terms. More than you thought you were getting into, isn't it? So again, you have a decimal as your percent. You put it over 100. But to get rid of the decimal, you might have to multiply by 10 or even 100 or even 1,000, depending on what place that's in. Then you reduce. All right, convert 316 to a fraction. I'm going to check myself. So that's 316 out of 100. But that's not lowest terms. So I need to divide at least both of them by 2. So 316 divided by 2, how about by 4? Let's try the 316 divided by 4. Okay, 316 divided by 4, 79. And 100 divided by 4 is 25. There we go. That's lowest terms. So that's how this works. Remember, percent means out of 100 when you're changing that to a fraction. Okay, folks, we're almost there. I've got this page and one more page, and then I'll be quiet about decimals. These are a little confusing, especially why. I want to address this 2 different ways. 3 1/5%. Now, I know this looks weird, so that'd be 3 1/5 out of 100 by definition, right? We could handle this. Watch this. I might only do it one way. Now, what wasn't discussed in your fractions sections was how to change a mixed number to an improper fraction, because that's just not on our state list of have to do, yet we still have to be able to do it right here. So watch this. I have 3 times 5 is 15, plus 1 is 16 fifths. Did you check that out? Again, I said 3 times 5 first, so I multiplied right there, and then I added the 1. So I have 16 fifths over 100. Now, you do know how to divide fractions. Where did that 1 in the denominator come from of the 100? Because there's always a 1 when you're dealing with a whole number. So what I'm going to do is say 16 fifths times 1 over 100. And then I can say 16 times 1. Actually, these will reduce. They'll both divide by 4. So 16 divided by 4 is 4. 100 divided by 4 is 25. So 4 times 1 is 4. 5 times 25 is 125. And that is lowest terms. So take a minute and work on the next one. It works just like this one. So how'd that guy go? Did you get 22 1/3% written as a fraction okay? So remember what percent means. All that means is out of 100. So 22 1/3 over 100. That's the easy part. My problem is 22 1/3 divided by 100. It's not in the right form to do, so I can't work with this mixed number story right here. I have to make it an improper fraction. So how do I do that? I multiply 22 times 3, which is 66, and then I add the 1. So that's 67, and keep that denominator of 3 divided by 100. Now, I'm dividing by 100, so I'm going to put 100 over 1. So I've got this fraction divided by this fraction. We know how to do that because we spent a lot of time dividing fractions. 67 thirds times you multiply by the reciprocal. That's 1 over 100. 67 and 100 do not have any common factors, so that's 67 over 300 is the final answer. That will not reduce at all. So 22 1/3% is the same as saying 67 parts out of 300 total parts. Woohoo! Finally to the last page of this long-winded video. I apologize. Now, we're converting a decimal to a percent. Now remember, this is backwards. So remember when we went from a percent, we didn't do a bunch of them, to a decimal. I can't spell decimal now. You move 2 places left. Okay, we're doing the opposite. So if we go from a decimal to a percent, we move 2 places right. Okay, now here's what helps. A percent is always a bigger number than a decimal. So if I'm trying to make 0.15, which is 15 hundredths, right, a bigger number, I would have to move that decimal that way. So just remember, percent number is always larger than the decimal number. So if I move that 2 places, that'd be 15. You also have to add the percent sign. So that's 15%. I move this dude 2 places to the right. That's 125%. And I move this guy 2 places to the right. That's 6.25%. And finally, down here, 2 places to the right, that's 235.8%. You see how lazy I was being during these last two guys? That's really 6 25/100%, and this is 235.8%. Okay, I hope you feel better about decimals. Take care.